So let's move on to the next question, guys. In this question, we are given that there is a triangle, right, whose hypotenuse is given to be 10. And we have to compare the maximum possible area of this triangle and the number 25, right? So we have to find the maximum possible area of this given triangle. Now tell me one thing. I think a few videos back I told you that when we have to find the maximum area of any given triangle, we try to do it by assuming that it is an equilateral triangle, right? So for any given triangle, the maximum possible area will be that of an equilateral triangle. Why? Because whenever we have to find anything maximum, we try to bring in more symmetry. For example, in equilateral triangle, there is a lot of symmetry, right? All the sides are equal, all the angles are equal. So whenever we are trying to find anything which is like maximum area or something like that, we try to bring in more and more symmetry over there. Now tell me one thing, we have to find the maximum area of this triangle, right? So anybody would say that, okay, let's try to assume it is an equilateral triangle, right? But we cannot assume this to be an equilateral triangle because there is a hypotenuse involved in this, right? So that means the AB side and the BC side both will be less than 10, right? Because we know in a right angle triangle, the hypotenuse is the longest side, right? So if we want this case to be converted into equilateral triangle, this is not possible because the side AB should be less than 10 because it is hypotenuse, and the side BC should also be less than 10 because it is hypotenuse, right? So equilateral triangle is not possible in this case. But as I said, we need to have more and more symmetry in order to maximize the area. So if equilateral triangle is not possible, so let's move on to the next level of symmetry, which is an isosceles triangle, right? In which two sides are equal. So can we have an isosceles triangle over here? Yes, we can have, right? Because if we make this side is equals to this side, if these two sides are equal, then we can have it, right? So let's assume that this side is equals to this side. For example, if this side is x and this side is also x. So this side is x, this is x, and we have a right angled isosceles triangle whose hypotenuse is 10, right? So if we solve it, so x square plus x square is equals to 10 square. So 2x square is equals to 100, right? So that means x square is equals to 50. So x is equals to root 50, right? Which is how much? 5 root 2, right? Okay, which is 5 root 2. So we have found the value of x to be 5 root 2, right? Now, in order to find the area, what will the area be? The area will be half into base into height, which is half into x, which is half x square, right? Which is half into, what is x square? X square is 50. So this comes out to be 25. This means the maximum possible area of this triangle is 25, right? And so this is 25, this is also 25. So since both are equal, the final answer becomes C. I hope this should be pretty clear. So in all these questions, what we have to do is that we have to bring in like more and more symmetry, right? Equilateral triangle was not possible in this case. So we moved on to the next level of similarity of symmetry, which was an isosceles triangle in which these two sides can be same. I hope this should be clear.